Today I will discuss thin layer chromatography. Thin layer chromatography is one of the chromatography technique. It is least expensive and faster technique, simple technique. So the TLC technique involves mobile phase, stationary phase, and analysis is performed on a flat surface under atmospheric pressure and room temperature. It is used for the separation or identification of the mixture of components into individual in separation or identification of mixture of components by using the stationary phase and mobile phase. The steps in TLC technique are choice of adsorbent, choice of solvent, method of production of thin layers on the plates, and application of sample on the plates. After application of the sample, selection of the development tank, and chamber saturation and development. Selection of the stationary phase. So there are different stationary phases available in thin layer chromatography. Chemical composition of the stationary phase is important to consider. It is stationary phase is selected based on the analyte. Stationary phase is nothing but the thin layer of adsorbent coated on the plate. Mobile phase is the developing liquid which travels up the stationary phase. The stationary phases used are different examples of stationary phases: silica gel G, silica gel G, silica gel containing binder, gypsum as the binder, and silica gel GF is silica gel plus binder plus fluorescent indicator. Silica gel H is silica gel without binder. Other examples of stationary phases are alumina, cellulose powder, Kieselguhr G. Next step is selection of the mobile phase. After selecting the stationary phase, mobile phase is selected based on the analyte. So, if the stationary phase is hydrophobic, benzene, cyclohexane, mixture of benzene, cyclohexane, and chloroform can be used as the mobile phase. For a hydrophilic stationary, for hydrophilic analytes, water and butanol is used as the mobile phase. Selection of the adsorbents. These are the factors considered in selection of the adsorbent. Preparation of the plates. TLC plates are of different sizes. 20 length of the TLC plate, and this is the breadth of the TLC plate or width of the plate. 20 into 10, 20 into 20. The surface should be flat without irregularities. The standard film thickness is 250 micrometers. The methods of preparation of the adsorbent or application of the adsorbent: pouring, dipping, spraying, and spreading. These are the 4 techniques. In pouring method, measured amount of slurry is poured and the plate is tipped back and forth to spread uniformly. The slurry is poured on the plate and it is allowed to flow over it so that it is evenly covered. In dipping technique, small plates are dipped into the slurry and the layer is prepared. Exact thickness of the layer is not known and evenness of the layer may not be good in the dipping technique. But spraying technique, slurry is diluted for the operation of the sprayer. Here the sprayer is used. Next, spreading technique. Spreading devices are available to spread the slurry onto the TLC plate. Commercial spreaders are of different types: moving spreader type and moving plate type. Moving spreader, the spreader moves here, and in moving plate type, plate is moved so that the slurry is coated onto the plate. Here the layer thickness is 0.2 to 2 millimeters. So we have discussed till now selection of the stationary phase and selection of the mobile phase. Next, activation of the plates. After preparing the TLC plates, the plates are activated by keeping in the oven at 100 degrees centigrade for 30 minutes. The solvent system used performs the following task: to dissolve the substances, to transport the substances, to give the RF values in the medium range, to provide adequate selectivity for the substance mixture to be separated, Mobile phase selection is based on these factors. Mobile phase selection is based on the nature of the substance to be separated, nature of the stationary phase used, mode of chromatography, normal phase or reverse phase chromatography. For example, in case of normal phase chromatography, non-polar mobile phase is used. In case of reverse phase chromatography, polar mobile phase is used. Storage of solvents. And these are the different solvents used in TLC. This is increasing order of polarity. This is less polar solvent, and water is the most polar solvent. N-hexane, cyclohexane, toluene, benzene, diethyl ether, dichloroform, dichloromethane, 1,2-dichloroethane, acetone, ethyl acetate, acetonitrile, propanol, methanol, acetic acid, and water. And application of the sample. Next step is application of the sample. After the plate is activated, baseline is drawn on the TLC plate, and these are the dissolve the TLC, dissolve the analyte in the dichloromethane or suitable solvent, dissolve the analyte in suitable solvent, use the capillary to transfer the analyte onto the plate. The area of application should be kept as small as possible for sharper and greater resolution. After sample application, the plate is kept in the development tank for development. There are 4 development techniques: ascending, descending, horizontal, and 2-dimensional techniques. The ascending development, the solvent flows against the gravity because of capillary action in the upward direction. In descending development, flow of solvent is assisted by gravity, hence development is faster. Next, in horizontal TLC, plate is kept in the horizontal position, and spotting is done in the middle of the plate, and mobile phase is added slowly through the sides. In 2-dimensional TLC, ascending development is carried out first, and the plate is rotated 90 degrees and once again kept for development. Detecting reagents used. So iodine vapor and sulfuric acid. This is one detecting reagent used, that is for unsaturated compounds. These are some examples of the reagents which are used to detect the analytes. Applications for separation of inorganic ions and in organic chemistry. So these are the direct methods. By measuring the area of the spot, analysis can be carried out. And second method is by densitometer. Intensity of the color is measured directly on the chromatogram. Thank you.